welcome to note set number 3. So today we're going to work on creating linear equations. So before we begin, an equation is a mathematical sentence that tells you what to do with your input in order to get your answer. But it has x and y. Where x is your input, like what you put in, and y is your output, which means answer. And so linear equations have two parts. They have slope, and slope was our last lesson. And so if you remember, slope tells you how much you're getting each time. So slope is the amount you get or lose. You can lose stuff each time. All right. In linear equations, we also have y-intercepts. And y-intercept is where it crosses the y-axis in a graph. In a table, it's where x equals 0. But in terms of our situation and what we care about, the definition you really care about right now is the y-intercept is how much you start with. So, big, how much you start with. And so in terms of our situations, that's the meaning of the y-intercept, is how much you start with. And so linear equations are special types of equations because there's tons of them. But particularly it's called a linear equation because it makes a straight line. So linear equations make a straight line when graphed. So when you graph a linear equation and connect all the points, it'll be a straight line. And that's what makes it linear. All right. So in general, a linear equation has a basic formula. And so the basic formula looks like this. Y equals mx plus b. So in a linear equation, m is where we put the slope, how much you're changing by, and b is where we put the y-intercept, how much we started with. All right. So let's just start working our way through this. Using your skills at writing equations from word problems, if you remember word problems from like unit 1, we're going to write the equation for the situation below. So I'm not going to use my formula that I just told you. I'm just going to remember my rules from like my word problems. Okay? So it says London has 10 cars. Each year she's planning on buying 2 more. If she has 18 cars, how many years has it been? So remember to solve something like this. We have to start with, what's my x? What don't I know? Well, I don't know. The question is, how many years has it been? So years is my x. So I'm going to search, where do they talk about years anywhere else? Oh, it says each year she plans to buy 2 more. So if you remember, we put 2 then, and then x, because we don't know how many years. But each year she gets 2 more. Then we take the extra, we make it equal the total, and it says if she has 18 cars, so that's her current total, so it equals that, And then we find the extra piece of information. And the extra is that she just had 10 cars. So on top of this 2 cars per year, she just had 10. So this is our equation from word problems. So if I were to solve it, I could figure out how many years this has been. So when I solve for x, what does x represent? X itself is how many years have passed. Because remember, x is usually time. Okay, and we're not going to solve it. But then the next one says, London, oops, look, her name got cut. London has 10 cars. Each year she plans to buy 2 more. So it's the exact same as this, but it's without a total. So it doesn't say if she has 18 cars. So if we don't know the total, instead of equaling 18, I'm going to have it equal y. It doesn't matter if I put the equal 18 here or here. It doesn't matter if I put the equal y here or on this side. People tend to like seeing the y first. It's the most common. So I'm going to start it with y equals 2x plus 10. So what was that y? Well, remember, the 18 was the total amount of cars she had at the end. So y represents the amount of cars, right? She has at the end. So if I said after 3 years, well, remember x was the year, so I'd put a 3 in there, and I'd solve it, and I'd figure out my y, and that would tell me how many cars she had. Or if I wanted to know after 5 years, I'd put a 5 into the x, and then I'd solve it, and then the y would equal how many cars she has. So I'm going to erase some of this, but I'm going to rewrite my equation up here, y equals 2x plus 10. So that I can scroll a little bit. Boop. So this y equals 2x plus 10 was my equation. And the question is, so what was the growth? What was my slope? Remember, the 2 was each time I was getting 2 more cars every year. So my slope in this situation is 2 because I get 2 more each year. And remember, each year is x, that's my time. So that's why the 2 goes with the x, because how many years have passed, like if it's been 5 years, I have to multiply that to 2 because she gets 2 per each year. So then the 2, the slope, always goes with the x, because how much you're changing each time needs to go with the time, and x is the time. Versus the y-intercept, the starting amount, she just had 10 cars because it's what she started with. And that just gets tacked on to the end without the x because that's just the starting amount. There's just 10 right there. But the slope, how much you're changing by, goes with the x because it's how much time has passed. Which brings us to why the formula is the way it is. So if we can go to the back page, we find I've written, where is it? That the formula is y equals mx plus b, where m is the slope and b is your starting amount, your y-intercept. And then for the situation, once I have the slope and the y-intercept, I can plug in any x I want. Like I can say, okay, what if this much time has passed? What if 3 years? What if 5 years? What if 10 years? So this x can change consistently depending on your situation. And it usually just represents time. And once you plug in x and get an answer, then your y, what it will equal, is your amount. But again, your y could be constantly changing too, because how much time has passed will change the amount you have. So we have some examples. Here's some situations. Oh, it's not even a situation. It's really easy. I'm just telling you, create a linear equation where the slope is 1/3 and the y-intercept is -5. So equations always have x's and y's. So y equals, m is my slope, and the slope says 1/3. And then I have to put x next to it. And then the y-intercept is -5. If it's a minus 5, you do not write plus negative 5. You just write minus 5. This one says create a linear equation where the y-intercept is 2 and the slope is negative 3. So the y equals m is my slope, which is negative 3, x, and then plus b, my y-intercept is a positive 2, so I do write plus 2. So that's really easy if it's in words, because you just plug the two pieces into where they go. On a graph, remember the y-intercept, the starting amount I told you earlier, was when x was 0. And x is 0 means it doesn't go left or right, which means it's on this line. Y-intercept also means cross y. So in this case, this 3, where it's crossing the y-axis, is the y-intercept. Then to figure out my slope, I have to make a slope triangle. So I'm going to connect this point to this point by going up and then over, so I get a triangle. And so my question is, for slope, it's how far up, so I went up 1, 2. How far over, I went over 1, and x. And 2 divided by 1 is just 2. So if I'm trying to write the equation of this line, it's y equals m, which is my slope, which is 2, x plus b, my y-intercept, which is 3.
Have your attention, please. Period 2 final has ended. Period 3 will start at 10:20. El periodo 2 ha terminado. El periodo 3 comenzará a las 10:20.
All right. On the table, so remember, y-intercept means it's on the y-axis, which means it has not moved left or right at all. Like the point's on this line. It does not move left or right from the middle, which means x is always 0 for our y-intercepts. So in a table, if I look here, bigger number is usually x, like which number is it, and how many tiles you have is usually your y. So your y-intercept is right here, because this is where x is 0. Then my slope, to go from 0 to 1, my x has only changed by 1. And from 2 to 7, that's a change of 5. So this is my slope. So then my equation for this table is y equals slope, which is 5x, plus y-intercept, which is 2. Is use the y part of the y-intercept. That's the equation of this table. This one, I said, well, what if I don't know the slope? If you remember, because this one, it went from 0 to 1 for my x, so my amount or my time has only changed by 1. Down here, my time changes by way more than 1. It goes from 0 to 5. So, to figure out the slope, remember, I do have the change and then the y, like how much y is going by, divided by how much time has passed, the change in x. Well, let's say I don't know to go from 0 to 5, I have to go by 5, or add 5. What I could do, or if I don't know from 12 to 27, going by 15, here's what you do. This is the first x. This is the second x. This is the first y. This is the second y. So these little 1s and these little 2s are just saying first one, second one, first one, second one. If you take the second y, the bigger one, and subtract the first one, you can figure out what you're changing by. So if I do 27, subtract 12, I would get 15. So from 12 to 27, I have to add 15. And if you don't know that in your head, you can always do the bigger one, the second one, minus the first one. Same thing for the x's. I can take the second x, the bigger one, and minus the first x. So then in this case, it would be 5 minus 0, which is 5. And then once I divide, I find out that my slope is 3. Then my y-intercept is where x is 0, so it's right here. Y-intercept. So my equation is y equals slope, I found to be 3 by using this formula, x, and then plus b, my y-intercept happens to be 12. So that's the equation of this line.